Okay students, we are going to find out electrostatic field at any point of an electric dipole. So let us find out that. Let us consider there is an electric dipole. This is a negative charge and this is the positive charge. This is the midpoint. This is the midpoint, and I have considered here a point, arbitrary point, distance of small r. Let us consider this point is Q, and this is the midpoint O, and the dipole moment of an electric dipole is, we can represent by P, and the direction of the dipole moment from minus Q to plus Q always. So this is the direction of the dipole moment. Okay, and this is the position, angular position of this dipole. So here is the coordinate of this point Q. This is r and theta. So r and theta that represents the coordinate of this point Q over here. So we are going to find out the electrostatic field with respect to this dipole at point Q. Now since this dipole moment, it is a vector quantity, so we can resolve this dipole moment into two components. One is along this side, cos of theta, and another is perpendicular to this. So this is p sine of theta. Right? So now the dipole moment has been resolved into two components. Now you just forget about this electric dipole. So we are going to find out the electrostatic field at point Q with respect to this dipole moment. We consider this is the dipole now, and we consider this is the dipole afterwards. So let us find out the electrostatic field at point Q with respect to this dipole. If this is a dipole with dipole moment p cos of theta, then this point Q is lying on its axis, right? So therefore we know that electrostatic field at any point on the axis of an electric dipole can be represented as K twice p cos of theta by Q. Right? So we have already learned about this. K2p by r cube. So here, this is the dipole with the dipole moment p cos of theta. This is the component we have considered. Okay, dipole moment p cos of theta. So instead of single p only, so we have written here p cos, twice p cos of theta divided by r cube. Alright. At the same way, electrostatic field at point Q with respect to now, this is your dipole with dipole moment p sine of theta. If you extend this way, so this is the dipole. Now if this is the dipole, so obviously this point P lie on its equatorial line. This point P lie on its equatorial line. So we know that the dipole moment at any point on the equatorial line of an electric dipole can be represented as P your sine of theta divided by r cube, where we already have learned about the electrostatic field on the equatorial line of an electric dipole. Right? So instead of P here, I have written P sine of theta. Why P sine of theta? Because if you consider this the dipole, then the dipole moment of this dipole is P sine of theta. That is why I have written here P sine of theta. Right? So one case is for the electrostatic field equatorial on the equatorial line, another case for its axial and equatorial line. Right? So now The direction of the electrostatic field on the equatorial line would be this way, and the direction of this is the axial and this is the equatorial line. The direction of the electrostatic field on the axial equatorial line is in this way. So the direction of the electrostatic field on the with respect to the axial point along this y, it is so, because we have already learned if this is the negative charge and this is the positive charge, if this is the dipole, and if you consider on any point on its axis, the electrostatic field either along this way or along this way. So obviously the electrostatic field on its axial line always be lie on the same line. On the other hand, electrostatic field on its equatorial line, this is the equatorial line and this is the direction of electrostatic field for this q, this is the equatorial line, this is the direction of the electrostatic field for the minus q, and this is the direction of the electrostatic field plus q. So obviously this is the result. This is the result. So the resultant field for equatorial case always be opposite to the dipole moment. So in this case, if this is the dipole moment, so the electrostatic field equatorial opposite to this. So now this to the electrostatic field at point q with respect to this electric field. So the resultant would be, so the resultant root over a square plus square, let's put the value over here, EA, so here the value EA, so K square 4P square cos square theta divided by R cube to the power 2 plus K square P square sin square theta divided by R cube. By calculating on this, we'll get this. This is the resultant field.